In this problem, the first thing we'll do is identify what the unknowns are. So the question asks how much water and alcohol should he use in order to create this liquid extract. So we're going to let W equal the ounces of water, because as we read through we notice that we're creating a 12-ounce vanilla extract. So this can be a combination of water and of alcohol. We're going to ignore the size of the vanilla itself, and let A be the ounces of alcohol. So now we need to go constraint hunting to be able to help us figure out what our equations should be. Well, as we come back up here, we notice that first of all, the vanilla requires a 60% alcohol solution. So we need 60% alcohol. Now that's obviously not going to happen if we just use the Everclear, because that's 97%. That's way too strong. The alcohol is going to be diluted with water, which has no alcohol in it. So we have 60% alcohol, and we also need the constraint that we're going to have 12 ounces total. So this one's pretty easy to write. This one can just be written as the ounces of water plus the ounces of alcohol equals 12. Okay, well this question we have to be a little bit more careful about, because we're going to need to know how many ounces of each to put in. Alright, so the way we can set this up is to first of all think about what it means to have 60% alcohol. So if we have a total of 12 ounces, that means that 60% of the 12 ounces are going to be pure alcohol. So I'll start with that. Pure alcohol would be found by taking 60% of 12 ounces. So if you think about it, and you have a jar, and you could separate the alcohol from the water, if that were possible, then you would have 60% of it would be alcohol. The remaining 40% would be water. Okay, well, we need to make sure that we add the right amount of this stuff, because the problem lies therein that we don't have 100% alcohol, so we can't just add 60% of alcohol and 40% of water. We need to account for the fact that this isn't exactly 100% alcohol. Okay, well, how does this work? Well, the contribution of water to this is going to be 0% alcohol. So 0% in the water plus the alcohol contributed by the alcohol, sorry to say it like that, the alcohol contributed by the Everclear is 97%. So if you take 0% times the amount of water plus 97% times the amount of alcohol, then you should get 60% of the total mixture. Now if you simplify this, so now we're pretty much ready to solve, but if you simplify this guy a little bit, you'll notice that 0W goes away, and you just have 0.97A equals 0.6 times 12, which 0.6 times 12 is 7.2. And so you notice real quickly here that this equation by itself we can actually solve for A. So if we divide by 0.97, divide by 0.97, we can still use substitution if we want. In fact, we will have to do that, but we're solving this equation for A. So then we take 7.2 divided by 0.97, and this tells us that we would need about 7.4. We'll round to 2 decimal places. 7.42 ounces of alcohol. Well, that probably allows you to real quickly conclude that the remainder of up to 12 ounces has to be alcohol. So if we use the second equation to help us solve this, you might see it already. We're just going to have to subtract 7.42 from 12, and we get, let's see, we get 4.58. And we are done. So there's our alcohol content, there's our water content, and this is 7.42 ounces alcohol and 4.58 ounces of water.